In this video, I will show how to use my customized module to use GPA and GA morph. Okay, so first of all, you need to select the Landmark file we need here, and let's take a look at these Landmark files. Okay, so you can see this actually is the Landmark file we will put into the module, and here is the oral soft tissue and the landmark of the soft tissue, and here's the landmark of hard tissue. And so we use slicer morph, and we modify a little bit to let it become more of our usage. And here we execute the GPA analysis and PC analysis, and you can see the mean, the average landmark is here. And let's hide the other landmarks. Oops. And in here you need to specify the mesh you need to use afterward, and here we select the sample closest to the mean. Okay. Here, and the corresponding landmark. Okay, so let me execute it. So it actually kind of constrain this mesh into the average mesh. You use one of the sample mesh and turn it into the average mesh, and it is executed by doing the landmark. They use simplex spline transform. Okay, so here is our let's say average model, and you can see the landmark is here, and you can see we actually automatically select 90% of the principal component, and we will use in afterward for our GA module. So in here you select the sample you want this mean average mesh to turn into, and we will select let me check, and I think we will select sample 8, and sample 8 is let me check, sample 8 is okay. So we will choose the target landmark. So in here, the genetic algorithm will calculate the weights of these principal components to turn these averaged mesh into the sampled mesh. And you can see I can already by modifying these to make my model morph. Okay, it's a little bit laggy. It actually is morphing, right? Oops. So if I type in 30, you can see it is actually morphing now, and here's the original one, and it morphs according to these principal component. Okay, so now we will calculate the correct weights of these principal components to turn these mesh into the target mesh, because we only use landmark to morph these model, so the result might not be very satisfied, but we still will demonstrate here. So here the N stands for the population, and D is the dimension, is like 3 principal components, and B constrains the upper bound and lower bound of the real number these GA algorithm will generate, and we go with 500 epoch. Okay, so here we can check our target landmark and our mean average landmark here, and let me change the color. Okay, so the green one is the target landmark. So the GA algorithm will try to modify these principal components, the weighting of these principal components, to move these landmark. You can see I'm already moving these landmark according to these principal components using this box. Okay, so let's reset it. Okay, so okay, so let's run it, right? And so it's actually running, and we will wait for it to be finished. Okay, now the GA has calculated the weighting to let these landmark to align, and we will just type in the weights. Okay, -8.6047, and let's see if I can. Okay, I cannot paste it. And you can see that the result is not very satisfying. Oops, I just a typo here. Yeah, check. Okay, so you can see that the result is not very satisfying, but it actually is much better than the previous one, right? If we look at the A slice, you can see this point is actually closer in after the morph. Okay, so here is for the landmark morph. You can see if I drag these, the landmark will, yeah, the morphing. Okay, so let's see how is the mesh perform. Okay, so because the opening of the source mesh is very time consuming, so here I just open it for you, and you can see the blue one is the morphed mesh, and the yellow one is the, let's say, ground truth, right? And you can see the result is not very satisfying, but actually it works. The palatoglossal arch is kind of aligned, and the uvula is also aligned. So pretty much this is how my module work, and this module is one of the work of my most undergraduate research project, and big thanks to 3D Slicer community and the Slicer Morph community for answering my questions. And yeah, and also thanks the RMML lab and the most to give this opportunity for me to do research. Okay, so if you like this video, please leave a like and subscribe to the channel. And if you have any comment or any question, please just comment below. Thanks.